All this salt is making me thirsty. How to cope with salinity. Marla Reikman, a soil management specialist with Manitoba Agriculture and Resource Development, is here to share some words with us today. Marla earned a Bachelor of Science in Agrology and a Master's degree in Soil Science from the University of Manitoba. Before joining Manitoba Agriculture in 2007, she was the farm manager at the Manitoba Zero-Till Research Association and also a soil conservationist with Prairie Farm Rehabilitation Administration. Marla's main focus is to provide extension on dealing with problem soils and maintaining long-term productivity by managing the soil health. Marla's passion for soil has even crept into her personal life. She is known to create jewelry with soil in her spare time. With that, I'd ask for you to welcome Marla to the stage.
Can I talk now? I can talk now. That's great. Thanks. Okay, so today I'm here to talk about salinity. I am happy to have a crowd to talk about it. How many of you guys deal with salinity on your farm? How many have big areas of salinity? How many have the little tiny patches that are around the, yeah, a little bit of both? All right, excellent. A little from column A, a little from column B. There it is. Okay, so what we're going to do today is I want to step back and talk a little bit about the science behind the salinity, how it's coming up, because it's really important to fully understand how salinity is actually occurring in the field. You have big patches. Why do you have little patches? Where are they showing up in the landscape? And then from there, you can start making decisions on how you're going to manage the salinity into the future. And I will say this now, I will say this again and again and again. You will manage salinity. You will not fix it. You only can manage it. It's just the reality. Unless you're talking about man-made salinity, where you could maybe fix it to some degree. When we're talking about natural processes with how water moves through the soil and how salts move along with it, we have to figure out how to manage and kind of cope with this idea. So the first big message, salinity is not a salt problem. Salinity is a water problem. Okay, if you remember that, and then you start thinking about how we're going to manage salinity later on, you're going to think, am I managing the water? And if I'm managing the water, then maybe I'm managing the salts. So it all comes back to water management to start. And any of you who have seen salinity in your fields knows that it's not just a static thing from year to year. So you might have patches that are saline, but they might get worse some years. And so we note that in dry years is usually when we see the salinity. But after long periods of dryness, you'll see that the water table here is low. And water moves upwards through the soil with the small capillary pores. I don't know if any of you remember in school using capillary tubes and drawing water up the tiny little glass tubes. And so that's what's happening in the soil in the very, very small pores. Water kind of sucks up through from the groundwater or saturated zone below, and it draws up. And when it does that, it draws dissolved salts along with it. Brings them up into the root zone, sometimes right to the surface of the soil, and that's how you end up seeing these white patches on the soil or evidence of salinity at the surface. When you have a deep water table, you're not going to have a salt problem because the salts can't get that high. On a clay soil, that capillary rise from the water table might be 5-6 feet, and so if your water table is deeper down, your salts can't rise quite as high. On a sand, that can only rise maybe 2-3 inches. And so it depends, again, on how many of those fine pores you have related to that soil texture. You start having wet problems. We saw this following 2011. It was really wet in the years leading up to it, and then all of a sudden the salinity kind of rears its ugly head as you see the kind of dry conditions show up. So in the wet year, you don't see the salinity necessarily as bad in its wet years, but the wet year is going to drive the problems into the future because that water table comes closer to the surface. Then you have a salinity problem showing up as we go through a dry cycle because now the water table is high, the salts are wicking that upwards, and then the salts are kind of coming up into the root zone. And then we start to see it decrease again as we start to get more water and heavier rains pushing the salts back down. But again, it's going to feed that water table. So it's a cycle, and it seems to follow along with those wet and dry years. So most of the time when we talk about salinity as a problem, we talk about two things. You have to have a high water table that can carry those soluble salts, and then you have to have evaporation that exceeds infiltration, which means that you have more upward movement of water or water leaving the soil than you actually have rainfall or precipitation leaching back down into the soil. So you've got this flip of more evaporation compared to precipitation. The third thing that often doesn't get talked about, which I always like to add, is that you have to have a plant that's susceptible to salinity, because if you have plants that don't die due to salt, we wouldn't be here talking about salt as a problem. So those of you who are growing forages or more tolerant crops, you might not see the salinity as bad as somebody who's growing less tolerant crops like soybeans or corn. So this is an example of a field that had been put into forage. It was used as a hay field, and then when crop prices were pretty good, 2006, around there, the farmer tilled up the field and decided to put annual crops in. And everything looked good for a year or two because he was growing wheat, canola, and then started putting pulses in and had this complete disaster. You can see areas like this. If you actually were walking in the field and wonder how a plant reacts to salt, it's actually that plant is dying due to drought. Even though there's adequate water in the soil, the water can't move into the plant. It's staying in the soil. And so the plant has drought conditions, but if you actually felt the soil, there's lots of moisture in it. So when he started talking to some of the soil specialists at the time, they were discussing this being a salt problem, and he went, oh, wait a minute, that's why I put it into forage in the first place. So for 10, 15 years, things look good, and all of a sudden, you think, I don't have a problem anymore. He was managing the problem with his forage. As soon as he took the management out, the problem came back because now he was growing annual crops that weren't using water the same, and they were more susceptible. And so he had to go through the process of putting this back into a forage again. We see this with corn. We've seen, pulses in general, corn, very sensitive, and they are going to tell you if you have a salt problem, even if it's just a mild salt problem. Comparing this to a crop like barley, so as you look at this slide, this moving to the right, it's increasing levels of salinity. So soybeans getting into this EC of 11.3, which is actually quite high. You know, the crop is completely gone by then. Barley has a lot more tolerance, so you can see the crop is affected, but it's going to tolerate the problem for a lot longer. We have this slide from NDSU where they've looked at actual crop yield or effects. So looking at relative yield and how that drops off with increasing salinity amounts. And the blue line and the red line here, soybean and corn, you get to that early little tipping point and the yield drops completely. So if you have salt problems, and I hate to say this, but the reality is some fields that are saline are not going to grow soybeans. They're just not. They're not going to grow corn. You are going to be restricted to more of the tolerant crops. So you look at things like wheat, barley, sunflowers. They had included sugar beets again because this was coming from North Dakota, a lot more tolerance. When I first started in this position, 2010, I used to get calls with people telling me that they had a salt problem that they had never had before. Brand new. They're from the Red River Valley. New problem. And I kept saying, well, it's not really a new problem. It just keeps coming around. It cycles. So I start talking to the farmers who were calling, and what had happened in their rotation is they were including soybeans. And once they started including soybeans in the rotation, this mild salinity problem that they always had never really showed itself because they weren't growing an intolerant plant. And as soon as they added soybeans into the rotation, now the soybeans are suffering. It was a new problem, but it always had been there. So again, it's the salt tolerance of the crops we're growing has a big impact on how you guys have to handle the situation. So just as an aside too, a lot of times people ask me about how certain crops actually avoid or deal with salts. I often will hear, well, I'm going to grow this forage in the saline area. I need to actually bale it up and move it off because the plant is taking up the salt. So the only way I can remove the salt is by getting the plant material out there. There are some crops that actually will tolerate or accept salt or take more up. Others just avoid it. So in a lot of cases, it's almost like they're crops that are more drought tolerant, so they can survive in a saline area. It doesn't mean that all crops are actually taking up the salt. So baling off the material doesn't necessarily mean that it's going to decrease the overall salinity over time. It might take some out, but it's mild or minor compared to the total amount of nutrients and salts that are actually left behind. There's three main mechanisms that we end up seeing for causing salts or where you see it in the field. So if you think about something like regional salinity or these artesian discharge, this is as if you're looking at the bottom of the escarpment. So think Miami area, the bottom of the escarpment, there's these big tracts of soil at the base where there's actually high salinity that show up in these big, large patches. Does anybody from that area see this type of salinity? And what's happening here is you actually have the area at the top of the escarpment up here. We call this a recharge zone. So it shows on the slide that it's non-saline. There still might be mild salinity patches in there, but for the most part, what's happening is precipitation that falls in that upper landscape area is really moving into the soil. It's driving the height of the water table. And as you get down to these lower lying areas, the water table comes closer to the surface. The discharge is the upward movement of water to the soil surface, drawing the salts along with it, and that's what we consider a saline area. This is a large area when we're talking about regional salinity. It's not something that's just happening in the field. In the field, we see issues like bathtub ring salinity. So prairie pothole country, you know that ring that's around the wetland, around any areas where water is lying, and you end up with these spaces because of the fact that the water table gets higher right where that slough is. The water is actually being drawn up out from that slough, and it kind of draws up and draws the salts along with it. I should stop moving so much. And then you get this ring of salinity all the way around that slough. Now, when I managed the zero-till farm, which is north of here on the Brookdale Road, when I was there, there was a few potholes and wetlands that didn't have any salinity around them, and those are the ones that still had willows growing, because the willow was actually intercepting that water, keeping it drawn down. And so I'll get to that when we talk a bit about how to manage bathtub ring salinity or deal with this. Before I step away from this slide, though, this is, if you imagine cutting this slide in half, this is the exact same thing that's happening with roadside salinity too. So when you see that area along the headlands, not right at the edge of the ditch, but inside from the ditch a bit, and then you have this patch where nothing's growing very well, or it's filled with kochia or foxtail barley, right? Those are indicator weeds for when you've got a saline problem. That space, again, the same thing is happening. The ditch holds water, it changes the hydrology, that water is moving out and it comes up and it draws the salts along with it. So it's upward movement of water along that road that's actually causing the problem. It can only go one way because the other way where the road is impermeable and it can't actually access it. And then the other one is side hill seep. So sometimes you'll have those areas that you get really stuck in on the edge of the hill, like not at the bottom, but halfway up. Or you see these areas where the salinity kind of comes up there. And again, you've got water moving, and it's a space where water actually comes closer to the soil surface, and that capillary rise kind of creates that saline area. So these are kind of the main three that we end up seeing for what causes salinity. Once you know you've got a problem, and you know you've got a problem, if you've got kochia, foxtail, barley, nothing growing, or just a big patch of white, you know you've got an issue. You want to diagnose how bad it is in order to try to figure out what the best management strategy is going to be. So that diagnostic is by using a simple soil test. You send it off. They test it for electrical conductivity. Electrical conductivity is not a direct measurement of salt content in the soil. It's an indirect measurement. And they will express it in a bunch of different ways depending on which lab you go to. So it'll say decisiemens per meter, millisiemens per centimeter, decimos or millimos per centimeter. Doesn't matter what the unit is. It's the one time in like mathematics and science where the units are all the same, and it doesn't matter. The number will always be the same. So if it's 1.2, it's 1.2, no matter which one. You want a soil sample at the 0 to 6 and the 6 to 24 inch depth to analyze for salts, because where are your salts coming from? Bottom. Right? They're going to be coming, they're moving up. So you want to monitor this, and you want to keep an eye on it from year to year, because again, a single snapshot in time doesn't actually tell you the story. You need to watch what's happening with your salts over time, and you need to watch where they're coming from with depth. You can also do mapping, so people will use an EM38 or a Veris map. It's important, though, that if you use some of these pieces of equipment, you need to also calibrate that the number that this equipment kind of spits out as it's running across the field. So you do have to still take soil samples and have them analyzed at the lab in order to verify the difference. An EM38 is measuring electrical conductivity in the soil, and it changes due to salt content, due to water content, and due to clay content. And because our soils are not the same soil all the way across, they're not going to be the same moisture content all the way across or salt content. All of those different reasons can change the number. So you need to verify why that number is changing. It's not just salt for the most part. The biggest, most complicated thing that I have in pretty much everything that I do in soil management extension is the issue with the type of analysis done in the lab. So when you take a soil sample and you take it off, send it to AgVise, send it to A&L, send it to someone who's going to run an analysis. They are going to do a 1-to-1 soil to water test. So equal parts soil and water mixed together, they kind of shake it up for 5 minutes or so, let it settle for a bit, and then they put a EM38 like an electrode in, take a reading, done. It's easy, it's fast, it's cheap. It's the reason why this is what you get done. Now, the problem is that the researchers, the people who are writing the papers, who are documenting the tolerance level of different crops to different amounts of salinity, they do a special test called saturated paste. And saturated paste is where you take that same amount of soil, you add just a little bit of water to it so you get a bit of a slurry, and then you put suction on it. You draw the water off using kind of a vacuum, and then you analyze the salt content in that water. The salt content in that water will be about 2 times as high as the salt content in the cheap fast test that you had done. So the problem is, if you have your analysis and you're trying to compare it to some research number or some plant tolerance number, you have to take your number, multiply it by 2, and then you can compare it to that research number. So it's tricky. If you forget about the multiplying by 2, you just call me. We talk through it on the phone. We'll figure it out together. But if you're trying to deal with deciding what the best strategy is for putting in a tolerant plant, you do need to recognize that the tolerance number may not be used with the same type of analysis as yours. So this gets confusing, especially when we have maps or graphs like this, which I showed you earlier, that starts at 0 and goes up to 24. Well, that's using the saturated paste test. So what you actually need to do is divide those numbers by 2, and then you can compare it to your test. So now it's 0 to 12. Remember that. Okay, so we've identified a problem. We've sent off an analysis. We know how bad it is. We have to now figure out what we're going to do. So what's the coping mechanism? Well, the first thing that I want you to do is I want you to look at your yield maps. That's the thing you can do right now, because there's not much we can do about it right now, but the first thing you can do right now is you can identify where the problems are. So if you've had any soil testing done, if you have any maps or areas you're pretty sure that it's salinity that's causing the problem, I want you to identify where those severely affected areas are, and then in the short term, I want you to stop wasting money on them. Can we do that? I don't know. It's okay. Let's stop wasting a lot of money on them, because if they're not growing very well, you might not want to have to just put a bunch of inputs down into an area that's not using the inputs you put down every year. So let's say with fertilizer, simple, don't fertilize it, because you're probably never using the fertilizer up on a yearly basis anyway if crop's not growing very well. And when you soil test, you're never actually soil testing those areas. You leave them out of the soil test. So you haven't really tested how bad the spot is or how much nutrient might be left behind in some of these areas because they're not being utilized. And then once you've first stopped spending money on them, then you're going to figure out how to invest in them, because there is a plan that you can put in place to try to invest in them, to make money off of them potentially, or maybe just stop the bleeding and not lose too much money on them. But you do need to soil sample those areas if you're going to manage them separately to figure out, okay, how bad is it? And then what level, what kind of crop do I know will grow there? How saline tolerant of a forage do I need to use? That kind of thing. So with the management, I want us to go back and think about why salt happens. So we've got high water table, we've got evaporation that is exceeding the precipitation, and then we have a plant that is susceptible to soil salinity. So we're going to make a chart, and we are going to look at our management options for salinity. So the first section, lowering your water table, right? Water table's too high. How are you going to lower your water table? Ideas? Pardon? Grow forages? Okay, I'm going to keep that one for crop choice. But that is one way to lower your water table. Actually, it is in here. Pardon? Drain the slough. Okay, well, I work for the government, so I can't encourage that idea at all. But, okay, so is draining a slough going to lower your water table? No. It's surface water. It's maybe decreasing the amount of added surface water. So surface drainage isn't going to lower your water table. What kind of drainage can? Tile drainage. Okay, so we are going to look at growing forages or using strategies to increase crop water uptake. And then we are going to look at the possibility of lowering salts through tile drainage, because you're lowering the water table. So strategic cropping is the first one to manage water. So I want you to think about using high water using crops where there is water, and using salt tolerant crops where you have to grow that, right? So a field like this, using high water using crops, could potentially draw down the water table. I don't know that you're actually going to fix that problem, because that problem is pretty white and pretty difficult in terms of how bad the salts are there. But you can look at how you could strategically plan for that field to manage based on crop choice. Get your weeds working for you. Who would listen to Tammy today talk about weeds? Tammy and I have done a lot of road trips last winter, a lot talking about kochia and salinity at the same time, go figure, because management of kochia and management of salinity kind of go hand in hand. So I've had farmers come up to me and say, Marla, I've been listening to you about this, and I started mowing my weeds, and things are looking a bit better. So you've got weeds. Okay, first of all, there's a problem with the green one that's left behind, and that is for Tammy to talk about, obviously not me. But that is not doing anything for you. Spraying them out, tilling them under, doing all that, it's not working for you. You can actually allow that crop to grow. If it stays greener, if it continues to vegetatively grow, it can actually use water, and that's what you want to do, right? So the easiest way to manage those areas is to get out and just mow those spots. Don't let them go to seed, and keep them vegetatively growing, keep them transpiring water. And some people have actually listened to me and are finding that it's working, which is good. But again, it depends on what weeds you're dealing with, how easy it is, if you've got the time to get out and mow them down. But that is one way to do it. Planting a buffer crop. So something around those sloughs or along that roadside to try to use up the water to decrease that movement. Remember this slide about the bathtub ring? Well, what if you put alfalfa in? I know that that's not alfalfa. But what if you put a plant in or something growing to decrease that water movement, cut off that water movement, and actually allow no more upward movement, and now any rainfall can actually leach those salts out, and you can manage it that way. Right? So again, that's actually one of the idea of putting an alfalfa strip along your roadside in the area that's still growing okay, because that first bit grows okay. It's the area inside that isn't. This part's going to come back into production as those salts start to leach down once the alfalfa is working to use up that water that's moving through. So it's an easy one because it's just taking a little edge off the headlands. It's keeping your field square. It's not having to manage around something in the middle of a wetland or low-lying areas. I get that it is more difficult to manage around, but these are medium and long-term solutions when we're talking about crop management to use water and kind of think about it as a long-term solution, let's say. It's not a quick fix. Tile drainage is the one that lots of people ask questions about, and yes, tiles can decrease salinity because they're lowering the water table. The thing is that you have to have precipitation wash those salts out through the soil profile out into the tile. And so if you're installing tile and say it's dry for a few years, your salts aren't really going anywhere during that time, because if the tile's not running, it's not actually leaching any salts out. The other thing I want to point out from this AgVise work is that this is the original, this line, the red dotted one, is the original line from the level of salinity when they first installed the tile. 9 years later, it's down to this solid red line. They took it down about 1 point on the salinity scale. They were starting around 2, 2.5, 3, and dropped down to about 1 to 2. If you got really extreme salinity, 9 years to wait for it to come down to a level that you might be able to grow crops might take a lot longer than 9 years too, right? And it depends too on having precipitation. So this is not a quick fix either. Yeah, it's an engineered response and something that we can do, but it does take time for that salinity to come down. How are we going to deal with infiltration and evaporation? What can we do to decrease evaporation rates from the soil? Keep the soil covered. Yeah. Eliminate tillage. Absolutely. The absolute worst thing, so keeping soil covered, let's start there. You can decrease the evaporation by leaving some kind of manure, straw, something, plants growing there, anything on those saline patches. This is only really feasible in small areas. I have heard of people shredding bales on those patches, right, just to keep it covered, decrease the evaporation. Might not be the most effective solution, but it's a way to keep it down and keep the salts from coming up. With the tillage, though, if you do absolutely nothing else, do nothing at all, please, don't till these areas. You're just going to make the problem worse. And this is where the weed problem, where you've got weeds that you're trying to control in those saline areas, it's like, how do we balance these ideas, right? But the worst thing that you can do is till them up. Now you've killed the weeds, and maybe you need to do that in order to establish a forage, but get that forage growing as fast as you can. Don't leave that soil black, because it will just turn white. Right? So don't leave it tilled. You're just encouraging more upward movement of water. And so it's not a good idea to be tilling these areas if you want the problem to go away. Last one, crop choice. So planting saline-tolerant annuals. If you're annually cropping, and using saline-tolerant forages, especially if you're dealing with really bad spots. So this comes from our Manitoba Soil Management Guide. And this chart, remember when I said something about the saturated paste versus one-to-one test? This is looking at plant tolerance to different levels of salt. So the plant tolerance, that 4, 8, 16, that's using the wrong test. To compare it to yours, you have to decrease or divide these numbers by 2. And now you can compare it to your soil test. So if you're dealing with crops in areas where you're in like an EC of 2 to 4, barley, rye, wheat, oats, flax, canola, that's the kind of stuff that's going to tolerate growing in there. Just like that early yield graph showed, your soybeans and corn are not going to like you. They're not going to do well if you're above that level. So they're going to tolerate up to about a 2. I'd prefer to even see soybeans growing on like 1 and less, if possible. Forages, you've got, again, same thing, 16, 8, 4. We're going to cut those numbers in half so we can compare them to your soil tests. And you've got a number of different forage options. But again, if you're going in and putting in a forage on a saline area, maybe you want to target one that's most appropriate for that, because you don't necessarily have to go to something that's less palatable and has high salt tolerance if your salinity levels are kind of moderate. So you want to target something that's kind of most appropriate. There are some more saline tolerant alfalfas. Alfalfa, I will caution though, even the saline tolerant ones, they don't like salinity when they're getting established. So getting them established during the really saline kind of part of the cycle is maybe not the best idea. And you can get up into things like AC Saltlander and a lot more forages now that have been developed that have better palatability to be used in the really, really saline areas. So again, preventing it though, like once we've got it, we've got it. You can't really get rid of it or prevent it completely, but you can do things to minimize it and make it not so bad. Reduce tillage, improve your drainage, use high water using crops, increase soil organic matter, do annual soil testing so you can actually watch what's going on with your salts from year to year, establishing buffer strips along the edges of fields or around some of those saline areas. Again, it is a management tool, and the management is to manage not the salt, but the water, right? So you're managing for water, so I want you to be skeptical of quick fixes, because I haven't seen a product yet that you can spray on the soil that fixes your salt, because I haven't seen a product yet that you can spray on the soil that lowers your water table. And so remember, it is about managing for water, and then you know what you need to do in order to manage for the salt problem. And when all else fails, but when do you sell it? You sell it in the wintertime when it's white anyway, and nobody can tell it's white in the summer too. All right, so that is it. If anyone has questions, I don't know if I have any more time, but I'll be around in the back, and you can feel free to come ask. Yeah? Okay, I can take 1 or 2 questions. Anyone? Yeah. Yeah, so leaving willows around the slough. Yeah, I mentioned it kind of in passing and didn't bring it back up at the end there. But that would be part of that like management or of a buffer around some of those areas. The same idea as having alfalfa growing along the field in those headlands to decrease the salinity in there. Having willows around the sloughs and the wetlands is definitely beneficial. So you'll notice on areas they'll do these riparian area assessments, and one of the things they're looking at is the presence of some of those saline weeds to show that there's salinity, and quite often the ones that have the best ratings are the ones that still have willows growing around them. So leaving the willows is great. Planting willows or planting something else if you don't want willows that will actually use up water and be deep-rooted, and it's really about things that can tolerate it and use up the water in those areas can be extremely beneficial. And the beautiful thing is, yeah, you have to give up a little bit of land, right, to have that buffer growing, but it's going to get the rest of the land back into production and improve the rest of it. So you're giving up a little to get the rest of it that's around that ring or along that field edge back into production. You're going to have to talk to Kaminsky about that one and with his other hat on about trees for tolerance. We can definitely look into that. I don't know much more about certain trees, but I know that there definitely is. My neighbor is a forester, so he and I have talked about a few of these things when looking at potential salinity areas for putting in shelter belts. And so there are sometimes places where there can be some more tolerant trees, but I don't know if they're so tolerant the really bad places or the bad spots. Perfect.
Okay, Marla, I think we're going to have to cut it short now. For anybody who has a specific question, Marla probably would meet you just outside the doors at the top of the ramp or at the top of the stage. Marla, thank you very much. If we could just show our appreciation.